Hello again. We are back to talk about the Heisenberg uncertainty principle and how that applies to homework problem number 12. This homework problem is basically two questions in one. So we're going to have two goals. Goal one is just the first sentence. Calculate the minimum of certainty in the speed of a ball of mass 500 grams that is known to be within 1 micron of a certain point on a bat. So first goal, calculate min uncertainty of speed, knowing mass and position, which is Q in this formula. So that's goal number one. And then goal number two is for the second sentence. What is the minimum uncertainty in the position of a bullet of mass 5 grams, excuse me, that is known to have a speed somewhere between 350.00001 meters per second and 350.00000 meters per second. So we can reduce that to calculate min uncertainty of position. Knowing mass and the delta V, the what's the word I'm looking for? Uncertainty of velocity. Okay, so for the equations, we have one, Heisenberg uncertainty, which is delta P, delta Q is greater than h bar over 2. Now we're not given the momentum anywhere in the problem. We're given mass and velocity, but we know that momentum is mass times velocity, so we can say the change in momentum corresponds to the change in velocity. So putting these together, we have m dv dq is greater than or equal to h bar over 2. All right, so for part A, I'll call it with the uncertainty of the speed of a ball. We have this equation, and since we're calculating the uncertainty for speed, we can algebraically rearrange this to delta V equals h bar over 2m delta Q. And we can just plug and chug at this point. I'm going to start with the denominator first because it's bigger. 2 times the mass, which we're going to put into kilograms because, well, I'll show in a minute. 500 grams is 0.5 kilograms. And the uncertainty in the position is, we're going to put this 1 micron, but in meters it's 1 times 10 to the minus 6 meter. And then h bar is 1.055 times 10 to the minus 34 joules seconds. And we put these in kilograms and meters because joules is made up of a certain arrangement of kilogram and meter. I don't exactly remember, but this is the way that the units work out to cancel. So we're left with meters per second. Anyway, so plugging into the calculator, we get 1.1 times 10 to the minus 28 meters per second. This is the uncertainty in the speed of a ball. And this is a really small uncertainty. And when we look at this equation, we can see that delta V is proportional, inversely proportional to the mass, and the mass is so large. So that makes sense. A really big mass would result in a really small uncertainty. So moving on to part B, we're looking for position. So rearranging this equation, we get delta Q is greater than or equal to h bar over 2m dv. Same thing, just plug and chug. I'm going to start with the denominator. 2 times mass, which we're given is 5 grams this time, so 0.005 kilogram times. dv is just this subtracted by this, and this is 10 to the minus 5 difference. So 1 times 10 to the minus 5 meters per second with h bar on top. Oops, I didn't write 34 up there. I meant that. Joules times seconds. Plug and chug, 1.1 times 10 to the minus 27 meters. So 1 magnitude bigger. But we can explain this in a similar way. It's still relatively small, and when we look at this, we see that there's a relationship between the uncertainty in position inversely related to the speed that we're given. And this change, or this uncertainty in speed, is relatively large. It's not that small. So because this is relatively large, this is going to be relatively small, but on a bigger scale than here, because this was a larger uncertainty. So, makes sense.